Hi everyone. I wasn't around for a few days. I'm back. I'll try to record every day starting today. Let's take a look at today's LeetCode Daily Challenge. This is marked as medium, but comparing to yesterday's problem, which was the diameter of a tree, I think this one is more intuitive. It's easier for someone who has just learned about trees and graphs to think about this problem than yesterday's problem. Because let's see what the problem is. The problem says find the bottom left tree value. It's very like random thing that they want from a tree. Given the root of a binary tree, return the leftmost value in the last row. In the last row. So in this example, it's going to be 1. In this example, it's going to be last row, this row, so it's going to be 7. So how do we think about this problem? So if you know how to run a DFS or a recursive function on a tree, this shouldn't be that hard. Something you should notice is the order of traversal on this tree. What is the order of traversal on this tree? So first, when you are on the root, first you're going to visit the left subtree and then the right subtree. So that means on each row, the first number that you visit is the leftmost number. So one solution could be you can save the first number you see on each row and then just take the number from the last row. That could be one solution. But the key is this: you just need to pass the depth of each node to your DFS. For example, your function should look like something like this: DFS of node and depth. And whenever you are calling your left subtree, you should say DFS node left and depth +1, and DFS node right depth +1. That's it. So this is the and then when you start your function, like at the beginning of your DFS, you should just check if this is the first time I am seeing this depth, I'm going to record the value. Okay. All right. So let's take a look at one example and see how we solve this actually in action. So in order to solve this, we can share a variable between all of the functions, between all of the DFS functions, and all of them can modify that single variable. And we call that, for example, value. So the value is the actual value. And we also keep track of the last depth that we have visited so far. So I'm going to call it height in this case. So height is going to be -1, and this keeps track of the last row. So when you are visiting this row, this is going to become 0. When you are visiting this row, this is going to become 1. And when you are visiting this row, this is going to become 2. And when you are visiting this row, this is going to become 3. And each time, when you are visiting a new row, this value changes. Let's see what happens in this example. So first, we are going to call DFS0 with depths, DFS1 with depths of DFS1 with depths of 0. So remember, this is the node, and this is the height. This is the depths. Okay, so DFS 0. Oh, and this is 0. So at the beginning of our DFS, we go and compare depth with height. And we say, oh, this is 0. We have a new depth. So we update height. We say you become 0, and this was -1. And then you also become 1, which is the value of that node. And then DFS1 calls DFS2 with depth of 1, right? Again, we compare this depth 1 with 0, and we say, oh, we have a new height. We are visiting a new row. So we update this. This becomes 1, and this becomes 2. And then DFS2 calls DFS4 with depth 2. Again, we say, oh, a new row. This becomes 2. This becomes 4. Okay, DFS4 finishes, DFS2 finishes, and then 1 calls DFS3. So DFS3 with depths of 1. We compare depths with height. This is 2. So that means we have already visited 1, and we don't care about that because we only care about the last row. We keep going. DFS3 calls DFS5. And depth 2. Again, we compare 2 with this 2. We say, oh, thank you. We have already visited some node from row 2. So we don't update height. We don't update value. DFS5 calls DFS7. So DFS7 and depth of 3. We compare, we say 3 and 2. We say, oh, we have a new height. So we compare that. We update that. And we save the value. That's it. And then all this finishes. We don't care about this 6 because the depth is 2. And that's it. We just returned 7. So the code for this should be pretty simple. Let's go and write the code. So we need some variables to share between all of the functions. So that should be int value and int height. So before we call our DFS, we initialize both of them to -1. And then we do a DFS route with depth of 0. And then we return height. So I don't actually need to come to the whiteboard. The base case is pretty simple. Whenever the node is null, that means the node cannot modify the value nor the height. So we just, and here we compare depth to the current height. If depth is greater than height, we update value. Okay, we update that, and then just we call left and right. That's it. That is it, actually. We need semicolon. Okay. And wrong answer. What is that? It's -1, -1. Oh, sorry. We return. Sorry, height equals depth. Okay. And then we return value, not height. Yeah, it's past midnight, sorry. Okay, that's it. And then we submit. All right. So what I suggest you do is to solve this problem with another approach. For example, solve this problem with BFS as a practice or any other method that comes to your mind. It's a good problem for practice. And please follow and subscribe. Please introduce my channel to your other friends who are practicing. That means a lot. Thank you very much.